Okay guys, in this video lesson we are going to take our next step into our simple machines, and we're going to focus in on levers and what levers are. Okay, so first of all, let's define what a lever is. All right, a lever is a simple machine. Okay, it has to have a rigid structure to it, and it has to rotate about a fulcrum. Okay, so think about anything that we use, from a shovel to a scissors to a wheelbarrow to the door on your car, any of those kind of things. The actual joints in our bodies create levers. All of those things are levers. Okay, so if we take a look at, or probably the most common way that we can design or look at a lever from a very simple standpoint, is the idea of a teeter-totter or a seesaw kind of scenario. Okay, so to be a lever, you need to have some sort of rigid structure. So here we just have a beam of some sort. Okay, that beam has to be placed in a way in which it can pivot at some point along that beam at a fulcrum. Okay, so the fulcrum is that pivot point we call right here. All right, now the goal of a lever is that we use one part of the arm to produce effort from the fulcrum. We use the other part of the arm to produce a load from the fulcrum. Now, in this style lever in particular, they're on opposite sides of the fulcrum, but it doesn't have to be that way. Okay, there are cases where the load and the effort can actually be on the same side of the fulcrum, and we'll get into that today as we go through this. All right, so things like hammers, human joints, teeter-totters, crowbars, brake levers are all levers. Okay, show you an example of these over here also. So here, scissors, may not think of it as a lever, but it is. You have a pivot point here, you have your effort here, and you have your loads over here. So you actually have two different levers working together to create a cutting motion. Now, the actual cutting motion, those are actually wedges, but that's a whole different story. Hammers the same way. Okay, your fulcrum here, if you're prying up a nail, is at the head of the hammer. Your effort's over here, your load's over here. Wheelbarrow is interesting because you have your fulcrum at the wheel, your effort's way out here, and now your load is in the middle. Okay, not much difference than a device that's used to crack nuts. Okay, I still can remember at like holiday times, my mom would always get out the nutcracker and she have a bowl of these random like walnuts and almonds and everything that we could crack open. So pivot point is here, you have a load here and effort here. And then of course you do have scenarios where your fulcrum is like in your body, where your fulcrum or your pivot point is at like the joint. The muscle or the effort is in the middle, and then the resistance is at the end too. So different ways of producing levers here. Okay, now let's go into the different types of levers and how we actually categorize them. Okay, so first of all, we have what's called the first class lever. All right, now when you do the different class levers, we want to focus on what is going on in the middle, not the middle, but between the other two things. Okay, so for example, in this scenario, we have the fulcrum between the force of resistance and between the effort force. Okay, so when the fulcrum is the middle object, and I don't want to say middle being the center, it's just between these two things, that's a first class lever. All right, so first class levers, if we take a look at them in a little bit more detail, you're always going to have the resistance, okay, is going to be moving in the same direction as the effort. So these two things are going to be the same direction when you have a first class lever. All right, your fulcrum will be between them. So somewhere in here you have the fulcrum between there. It does not have to be in the dead center. In fact, most of the time you don't want it in the dead center, because the idea of a lever is to either amplify force or distance, right? We're trying to get a thing to give us some advantage here, and put it in the center, all it does then is just changes direction. Okay, so the nice thing is you have your force of resistance is pushing down, your effort is pushing down. So if you apply an effort in, let's say, this direction like that, you actually can raise up your object. So your downward motion creates upward motion on the other side. Okay, so that's kind of how a first class lever works. And there, probably the most classic example of a first class lever is your basic teeter-totter idea, right? And most of us have either seen them or experienced them, where one person sits on one side, one person sits on the other side, and you go back and forth. Now in a teeter-totter, the fulcrum is in the center, but often you may shift your weight forward or back depending on how heavy you are comparative to the person you're teeter-tottering with. And that is basically using the principle of levers and how they work. All right. The second type of lever that we have is called a second class lever. All right. So we notice for a second class lever now, the difference is we have moved our fulcrum to the end or the outside of our lever arm, and the resistance now sits in the same or sorry, in the middle or someplace between the effort and the resistance, okay? So let's kind of break down a second class lever. So now a second class lever, biggest thing here is that our resistance is in between, so it's someplace between here and here is where we're going to find our resistance. Okay, it again does not have to be in the middle, and we don't necessarily want it in the middle. On the end, we have our fulcrum right here, and we have our effort on the other end. Now, with this, okay, the resistance is pulling downwards, but our effort is upwards. So as a result, if we apply a upwards force, we get an upwards movement to oppose this downward resistance, okay? So in this case, the force that we apply creates a movement in the same direction for our resistance, okay? So changes how that lever works. Your classic example of this, well, that would be your wheelbarrow, all right? So you have your wheel right here, and you have arms coming out to where you hold on, and you have your bucket someplace in the middle of that wheelbarrow, and that's where the resistance is, okay? So second class lever, probably the most common way to do that one is to visualize it is how a wheelbarrow works, okay? Now, our third class lever is our final class lever we have here, which would kind of make sense because we're rotating what goes in the middle or what goes in between the other two things for our levers. So we put the fulcrum in the middle for first class lever. We put the resistance in the middle for our second class lever. So for a third class lever, we now have our effort in the middle, okay? What's unique about a third class lever is in this scenario with a third class lever, we always have our resistance residing outside of our effort, okay? We're going to find out later when we start talking about mechanical advantage. This creates a scenario where we're always actually reducing the force that we input, and we're always amplifying our distance instead, okay? So it's a unique type of lever that we have with that. But let's break it down, all right? So again, we have our fulcrum on the outside, okay? So the pivot point's on the outside. Now our effort is in the middle and our resistance is on the outside. So very similar to second class lever, all we did was switch these two between second and third class levers, all right? Now if our effort is going up, we will still get an upward motion of our resistance on this one also, okay? The easiest way to break down the three levers is to focus on what is in the middle of these levers. So in the middle of a third class is your effort. In the middle of a second class is your resistance. In the middle of a first class is your fulcrum or your pivot point. Okay? So a lot of human joints, a lot of the way your arms work, your elbow works, your shoulders work, that kind of stuff. A lot of our actual joints are third class levers, to give you an idea. So for example, if you take a look at, like, say, our elbow here, we pivot right here. And if I'm holding some sort of, object that I'm trying to hold up, I'm pivoting right here at my elbow, okay? So, I don't know if you guys can see that or not. We'll see. I'm pivoting at my elbow, so this is my fulcrum. The resistance or the load is in this cup that I'm holding on to, and the muscles that I'm using, okay, are either inside here, or if I'm using my bicep, the bicep actually attaches on the other side of this joint. So when the bicep contracts, it pulls here on my arm, which then creates that movement, okay? So really, the effort is happening in here someplace, wherever that attachment point is. Resistance is out here, and my fulcrum is right there, okay? So that is our third class lever and kind of how they work, all right? So that's levers. In our next video lesson, we'll go on to putting some numbers to this and actually be able to calculate those ratios between effort and resistance and how far we can get them to move. Thank you.